So the next logical step is to move on to what I call logistic regression. Why? So far we have looked at predicting continuous outputs, right. We have did hypothesis testing again on continuous cases, we also did it on proportions, okay. We have built a model for continuous case, now we are building a model for proportions. Remember our earlier when you did hypothesis testing, we did two things, one is for continuous variables, the other one is for proportions, right. So now on ANOVA we modeled for continuous variables, and linear regression is a formal way to build a model for continuous variables. Now we are trying to build a formal way for proportions, predicting the proportions, and that can be used to, that means you can use it to predict classes, and this is actually the method what we are going to call is learn is pretty old, but this is what an individual neuron in your machine learning or neural network is doing. Every neuron in your neural network is solving a logistic regression problem. Every neuron is solving a logistic regression problem. Every classifier whatever you know of is only solving a logistic regression problem, okay. So that is why it is very important machine learning tool and statistical tool necessary for all of these today's engineers, especially when you deal with data, okay. So what are we talking about in logistic regression? I will start with a picture. So we are talking about inputs which could be discrete or continuous. So these inputs could be discrete or continuous, there is no restriction there, it could be anything discrete or continuous, and you have these discrete and continuous inputs weighed by your weights, okay. So remember this is exactly like your biological model of a neuron. What do your biological model of neuron, how do you represent? If you remember Hodgkin-Huxley models, everybody learned Hodgkin-Huxley models, what does it do basically? How does an activation function is generated? I have no nerve action potential, how does it happen? No idea. How is a nerve action potential generated? Huh? Influx of sodium, outflux of potassium, influx of sodium, electrochemical gradient, blah blah blah. But where does it all start? From the input, sensory, all the way to back to the CNS. So the information is received as inputs, then they are all weighed, the weightage is dependent upon the input itself. So the number of neurons that get recruited as well as the pulse of the the inputs weightage is in terms of what? Is in terms of the number of pulses produced. Remember our neuron operates as pulse frequency modulation, it only outputs a 0 or 1, but the amount of zeros and ones, the frequency at which emits is the where the information is. So for a for a significant or important input or whatever, the frequency will be large, and for other cases the frequency will be less, right. So that is how information is transmitted. So the output of a neuron is only 0 or 1, either to fire or not. So similarly in this case we will take a binary logistic regression model where the output is only 2, binary case, yes or no, and you have a certain inputs that are weighed, that goes through a black box model, which is what we will learn today, and its output is either a 0 or 1. Clear? Is it making sense? How is it related? It is similar to the functioning of a neuron, it takes in inputs, weights it, and this is a non-linear model. And you all know how Hodgkin-Huxley model is a non-linear model, right. Hodgkin-HH model is also a non-linear model. So similarly here also the inputs are weighed and passed through a non-linear model to get the output which is either 1 or a 0. okay. So that is what the overall. So now we want to design this model so that it classifies accordingly. Again this is a supervised learning model, supervised learning algorithm. What I mean by that, you need to train it to classify things so that it can do well in the testing data, okay. So this is supervised learning algorithm similar to that of a linear regression, okay, but its output is truly binary or truly discrete. So the assumptions, if you talk about, the only real assumption is that the outcome must be discrete. So that is the only assumption, there is no linearity assumption here, it is non-linear, the model I said is non-linear, it could take anything as input, okay, it could take continuous variables or discrete variables as input. The only constraint is that the output should be by discrete, that means it should have only finite set of outputs. Huh?
For testing normality we use
yes.
For linearity, whether just for using those graphs we will
For linearity, that is what we said, after you build a model you look at the residuals. I told in the yesterday's class, when you look at the residuals, if you plot residuals versus your input, then you will see whether it is curvilinear, linear or heteroscedasticity, all of those assumptions can be taken care. So coming back, the only real assumption is the outcome must be discrete, and of course if there are too many cells with no responses, then the errors will blow up. So you need enough of training data. Suppose you have all data only for yes and very little data for no, then you are most likely going to make errors. This is what we call as class imbalance in machine learning, where we say there is more amount of data in one class and very less data in another class, then the error is going to be pretty high. This you would have seen in your 10 years back or 7 years back in your Siri or in your your Google Assistant. It will not work for, it will mostly work for Caucasian, it will not work for other ethnicity, because there is too much training data on Caucasian data and too little on other data sets. But today people try to patch it up with collecting more and more data across, okay. So you really need enough data for this to work, that is all, enough data in each group, each class. So training data should be good for in each class. We will come back to this linearity in the logic later, we will come back to this one. So there are three different types of logistic regression: binary, which is what we will begin with, okay, multinomial is 3 or more categories, like vegetarian, non-vegetarian, vegan, you have multiple categories, right. And similarly ordinal logistic regression, this is your Netflix or your Amazon Prime 1 star 2 star ratings, right. This is also logistic, but it is numbered, it is discrete, the output is discrete, but numbers carry some value. 5 is high, 5 is a good star, I mean out of 5 out of 5 is good, 4 is okay, like that, right. So this is called ordinal logistic regression. So there are typically 3 types of logistic: binary, multinomial, ordinal. Now we will only talk about a simple binary logistic regression, okay, a simple binary logistic regression. So you can look at this graph, okay, this is your x, and remember x could be continuous or discrete, my input could be continuous or discrete, my output is only yes or no, like like you look at an MRI. After looking at an MRI, what is the conclusion the doctor is going to make? Whether there is an abnormality or not. It is a simple binary output, but what is the input? What is the input? It is a video, MRI is a video, right, it is continuously streamed video, and he may look at various frequency patterns, how frequency spectral features are changing, lot of them, but the output is only discrete. Understood? You can see this in many cases. The inputs could be many continuous, but the decisions are usually binary or some classes. You do not have a whole bunch of outputs, continuous outputs. Typically it is discrete, but the inputs could be both continuous and discrete. That is what the case here logistic regression is. Now if I plot x as continuous and plot y, which is, let us say this is -1 and 1, how does it look like? Can I fit a linear regression to this? Can I fit a linear model to this? If I fit a linear model, how will it look like? Look like this. How will the errors be? Pretty bad. R square will be tending to 0, right, because your sum square error will be very high. I would not have fit any data point. So if I have to fit this kind of graph, what is the function you could think of? How does it look like? It is typically a without having jargons, it is an S-shaped curve. Okay, basically you look at this graph, I am just trying to use this graph to explain. So if I want to fit, I would like to fit like this, right, -1 to +1. So I want to fit a continuous, I want to fit a graph, so I will just start here and then jump there, okay, and I can play with the slope so that I could have multiple slow varying, fast varying, etc., right. I could have a variety of curves that I could fit by varying the slope parameter, by varying the rate of change of the graph, okay, the variation, how quickly the step changes, okay. So that is what we are trying to do. So we are trying to fit an S-shaped curve, and this S-shaped curve, actually if you look at even in your Hodgkin-Huxley, you will have exponential decay functions, etc., okay. This S-shaped curve is pretty very important curve because it governs the birth and death of organisms. So if you remember, if you even think about human life, the evolution of knowledge or whatever, kids until certain age beginning, you will not even notice anything happening cognitively. Let us say first 2 years, you will see that under 2 years everybody is a kid, you do not even, then you see 2 to 12 or 4 to 12, rapid growth in cognitive, right, very sudden change, you will see that they pick up everything. After 12 or 15, the cognitive aspect change will not be noticeable, it will be very subtle, right. If you take us and take a 60-year-old conversations, will it be very drastically cognitively different? No, but there is of course subtle changes, the experience that brings in, right. So typically the microorganisms, if you take their growth, initially they will feed on, then will not be growth, then there is a sudden spurt of growth, then they will die due to lack of food and aging, etc. So this S-shaped curve is a very common curve observed in nature, and that is why all this first generation second generation neural networks, they started using this function as called as an activation function to cancel the non-linearities. See, mankind is very good in linear algebra. If you ask, there is only linear algebra, there is no non-linear algebra theory, I keep repeating this. So we only do transformations to another domain to make it fit a linear model. I cannot fit a linear regression directly, but I can fit a linear model in a transformed domain, okay. So that is what we are going to do, we are going to make a transformation of the data, okay. We are going to make a transformation of this data through a sigmoidal function, okay. So x is transformed using a sigmoidal function or an S-shaped curve, so that I can fit a linear model in the transformed domain, okay. We will see this. So this is an S-shaped curve, and this S-shaped curve is typically written by e to the power z by 1 plus e power z, or 1 by 1 minus e power 1 by 1 plus e power minus z, both are same. These are two ways I will represent e power z by 1 plus e power z, or 1 by 1 plus e power minus z, okay. This z could be a linear equation, a function of parameters. So this the z could be beta naught plus beta 1 x, or this z could be simply x bar x times theta hat. If I wanted to write it in a matrix vector notation, so I have I have my sigmoidal function to be e power z by 1 plus e power z, where z equals to, what do I write, x times theta. So this is what I am going to fit. Instead of fitting a linear model, I am fitting a model passing x through a non-linear function, which is, what is this, S function, and I am relating it with y. Now remember, my output is continuous in this case if I do like this, but what is the real output I want, yes or no, discrete. Okay, so I cannot take directly this as my output. This function, whatever z value you will fit in, it will give you a continuous value. It is not going to be giving me 0 or 1 output. You understand? This function is a continuous function. The S function is actually a continuous function. It is not a discrete function. But my output is what? Discrete. Yes or no? How do I make a continuous function to discrete? Threshold. Put thresholds. So remember proportions. So this equation is not directly y, but this is probability of y given x, and if probability of y given x is greater than 0.5, then output is 1. If it is less than 0.5, then output is 0. Now I can make it as a class. Now I can make it to be a binary. I can make it to tertiary also if you want, 0.25, 0.5, 0.75. I can cover 4 classes, right. So what are we trying to predict, model? We are trying to not model y, we are trying to write an equation for probability of y given x. Probability is a continuous value between 0 to 1, and I put threshold on the probability to convert it into a discrete output. That is what this logistic regression model is. Okay, so it is a model which gives me output as probability of y given x. Yes.
For a single threshold, this type of function will work. Say for x less than x1 it is class 1, x greater than x1 it is class 2. Suppose after some threshold x2 it is again class 1.
No, so you are saying you have it as multiple classes, right. I have 5 classes, then you should have continuously 0 to 0.1 as this, 0.1 to 0.2 is the next class, 0.2 to 0.3 is another class.
Suppose only 2 class and more threshold.
Why would I want that? Where is the practical utility?
In the graph that you showed previously.
I do not want to, those are errors. Do you want to fit everything? Do you fit everything in linear regression?
No, it is possible like x after a certain value.
Then it becomes a new class, no? Then you call it as a new break, a new class. Why do you want to define it as the same class? You see, these are outliers. I cannot fit this, neither here, because there will be too much error if I try to fit this, right.
The plot itself is like some Gaussian curve or something, will have
Classes, where it Gaussian come?
no, the points are here, the point is exactly like an S shape. The point itself is like.
Then you define it as classes, multiple classes. You define it as multiple classes, then do a post processing. I can always do into multiple classes and then combine the classes later, nobody stops me, right. So coming back, so we are trying to predict probability of, we are going to model probability of y given x. So as usual the unknowns are z, unknown is z, which is a parameters. Okay. Now the question is, how do I solve, what is the objective functions, etc. And before we go on to do that, we want to know what is theta, what is the meaning of theta. In earlier case it was simple correlation and mean, but what is the meaning of theta here? So those are the questions which we want to answer. Okay. So we call it as pi of x. So you see here, for various values of alpha and beta I have plotted. So what does beta tell you? Beta actually determines the rate of change of what? Slope, the change in the graph, how quickly the graph or how quickly the function goes from one level to another level, that is determined by your beta x, right. So the beta determines how quickly the graph changes from one class to another class, okay. And what does alpha tell? What is in a binary classification problem, what is the point of confusion? When can you not classify? What is it? 0.5 is the threshold for a binary classifier problem, that is a confusion point. If my output is 0.5, you do not know whether it is 0 or 1. Alpha, if you fix beta, alpha determines the value of x at which the probability value is 0.5. That is the meaning of alpha, that is the significance of alpha. So look at this, so I have kept beta constant 0.4, 0.4, okay, the red and the pink both beta equals to 0.4. Now if you look at the value at which it is doubled, if alpha doubles, the value at which the probability is 0.5, the value of x with which the probability of 0.5, that also gets doubled. In other words, alpha dictates your confusion point, the point at which the probability is 0.5. The value of x at which the probability is 0.5 is determined by your alpha, and your beta actually determines your the change, the rate at which it changes from one level to another level, that is what beta is. So I do not want to get into the objective functions etc. So this is a quite a bit of math involved in the next class, okay. I would have derived a bunch of things, I will not do that today, then it will be overwhelming. So today I will tell you why the name is logistic regression, and then we will call it a day, okay. So we take, so there is a jargon which we will also learn. So we take odds of success. In this case in the particular example I have taken death to be a success, okay. So that is why I have had odds of death, but you know odds of success is what is equals to typically success by failure. So odds is nothing but ratio of success to failure, okay, that is what odds is. Odds of an event is nothing but success of an event divided by failure of an event. In this case what is success? In binary regression what do you want to call it as success? 1, okay, failure is 0. So what do I have? If I take probability of y given x, I divided by 1 minus probability of y given x, this is my odds of success, odds of a successful event, right. Probability of y given x divided by 1 minus probability of y given x. Now if I expand this, what do I have? 1 by 1 plus e power minus z divided by 1 minus 1 by 1 plus e power minus z. Can we simplify this? What do you get? So what do I have? E power z. So success by failure equals to e power z. So if I take ln on both the sides, ln of success by failure, I have written this is my sigmoid function, this is my sigmoid function pi of x, okay, I have denoted it as pi of x. So this is nothing but is equals to z. So ln of pi of x divided by 1 minus pi of x equals to z, right. So now what is z? Z equals to x times theta. Now this is a linear regression, this is a linear equation, The right hand side is linear, y equals to mx. Is this a linear equation? Now this function, okay, this function I call it as logit. This function I call it as logit of pi. Okay. So this log of success by failure is what I call it as logit. Okay. So this logistic regression is linear in logit function. This is linear in logit function. Okay. What is logit function? Logit is nothing but log of success by failure. Clear? This is what I call it as logit function. So the name logistic regression comes because this model is linear in logit. Okay, that is why it is called as logistic regression. Okay, clear? So now we have a linear model now, right? The right hand side is only x theta, left hand side is log function, logit function. So now how do I fit the model is the question. So far so good. So we understand bit by bit what is the parameter importance, why is it called logistic regression, why do we use S function, because naturally the S function comes in and it is nothing but 1 by 1 plus e power minus z, and I take a ratio of success by failure that is actually technically called odds. Okay, they call it as odds. Odds ratio is nothing, odds is odds of a success is nothing but success by failure. Okay, odds is like probability. If you take odds is, suppose 5:1, if I say my odds is 5:1, people instead of talking about probability they will use this term quite often. 5:1 is my odds, then what do I mean? My probability is 0.2, 1 over 5, 5:1, right? Success by failure, if you write 1 by 5, so that is 0.2 is my probability or chance of getting a success. Okay. So odds ratio, they call it as also odds ratio, these are things jargons used. This is odds by 1 minus odds. Odd itself is a ratio and you can have odds ratio which is odds by 1 minus odds. So I have given an example for the sake of completion. So let us say 7 out of 10 males are admitted to an engineering school. Okay, then what is the odds of a male? Probability is 7 by 3, success by failure, 7 by 10 is probability, 7 by 3, right, and for a female it is 3 by 7. So odds ratio, what is odds ratio now? Odds ratio is that is 0.7 by 0.3. So that is odds ratio of male is 2.33. What does it mean? For every female 2.33 male gets admitted, because 7 out of 10 is male. So for every female 2.33 male gets admitted in engineering, and if you take odds of female, for every male 0.42 female gets admitted. Okay. So odds ratio if it is higher, that means the chances are favorable, and odds ratio if it is lower, the chances are less. Odds is like inverse of probability, odds is like inverse of probability. Okay. So you want to know this jargon because in logistic regression people are in business community, they will typically talk about odds, they will not, what is the odds of winning, instead of probability of winning they will say what is the odds of winning. It is simply inverse of the probability. Success by failure, it is success by failure, it is not success by total. If it is success by total then it is probability. Clear? So if you look at odds ratio, then it is odds of male we have calculated, it is 7 by 10 by 3 by, odds ratio is 2.33 divided by 0.42, this is what the ratio I talked about. So what is it? It is 5.4. So the odds of being admitted are 5.44 times larger compared to a female. That is what odds ratio means. Odds itself is a ratio first of all, and odds ratio is ratio of success by failure. Odds itself is a ratio. For odds of a male is what? 3 by 0.7 by 0.3, that is probability of success divided by probability of failure. Probability of success is 0.7, probability of failure is 0.3. So 0.7 by 0.3 is what? Odds of male. Female also we know. Odds ratio is what? Male divided by female. What does it tell? It tells you how many times it is favoring a male compared to a female or vice versa. That is what, it is a comparison, odds ratios. Okay. Descriptive. So if you take odds ratio, what are we trying to say? I want to know how many times compared to a male, what is the chances of getting a female getting admitted. It is a comparison, right. So there is a 5.5 times, at least 5 times chances are higher for a male compared to a female getting into the college as per this data. Success and failure, yes. Clear? Make sense? So with this we will stop because I came to this because we are only taking log of odds. Log of odds is logit, and logit, the total equation is linear in the logit function. Okay.